My name is Mogens Isager, and I'm a physical IC designer at Oticon. Let me start by just telling you a bit about what we do at Oticon. Oticon is manufacturing and designing and manufacturing hearing aids and hearing aids solutions. We are located in Copenhagen, in Denmark. And with more than 100 years of history, Oticon is the oldest hearing aid manufacturer in the world. And actually it started all the way back when you just had this hearing horn that you stuck in your ear and hopefully could hear a little better. Nowadays the hearing aids are a lot more fancy, and we also have these streamer devices that actually allow you to use your hearing aids as a headset for your mobile phone. The net revenue of Oticon is just 1.25 billion last year, and we are one of the top 6 companies in this market. And as you can see, this market is just like Glenn noticed, also one of the growing markets, and seeing double-digit growths, which is one of the good words from financial side. Okay, so let me continue and tell you a little bit about what we do in IC design. Modern hearing aids, they require actually quite advanced technology, and we have to use a lot of integrated product development in order to make sure we can create a successful hearing aid. And in order to achieve this, we do everything ourselves, all the way from the algorithms in the hearing aid and down to the final layout that we ship off to the foundry. A hearing aid consists of 2 chips, one which is a fully digital DSP chip, and another chip which is the mixed signal analog front-end chip that handles HD conversion, power management, and this wireless interface that allows the hearing aids to talk to each other and also to the streamer device. Hearing aids, as you can see, the batteries, that's the little dot next to the AA battery there, they are very small, and we would like to run a hearing aid on that small battery for a week before changing it. So we are extremely limited on the power budget, and for the DSP chip, we normally say that it should not use more than 400 microwatts in normal operation. In order to achieve this, we run the chips at very low frequency compared to what I hear around here, and also at a very low supply voltage. Even though we run at low frequency and the low voltage means that actually we still have to struggle in order to meet timing of the chip. And another consequence of the low voltage is that we see huge variations between the minimum and the maximum timing corners of our operating range, and actually also almost up to a factor of 10 sometimes in this regard. And this means that we have to have a lot of in-between scenarios in order to meet timing over the entire range of the operating range, and therefore we end up having to implement with more than 50 scenarios normally. The IC design team in Oticon is about 35 designers, and we don't have a dedicated CAD department, and this is where we can get some help from the Lynx design system, because when we started to use the Synopsys tool some years ago, we had to make a decision whether we wanted to upgrade our existing old flow with all the new tools, or we should perhaps consider doing something else, buying in a flow so that we wouldn't have to start from scratch. And in the end, it was really a big decision because, or a hard decision, because we wanted to get started using the new tools right away. So Lynx, the predecessor, the Pilot, which is the predecessor to Lynx, was an easy choice for us at that time. And we actually managed to tape out and chip within 8 months of getting the new tools and the new flow. And actually, we even also migrated to a different technology node and had very many power management features on that chip. So what is also good about Lynx is that we can easily integrate third-party tools. For instance, in this tape-out, we managed to integrate the caliber physical verification. So Lynx provides for us the ability to focus on getting new tool features and methodologies without having to do a lot of flow updates. And it allows us to focus on the design and not the flow. And this, as an example of this, the chip that I'm currently working on, we wanted to start using a hierarchical flow. Luckily for us, you could say, Lynx actually already supports hierarchical design. So we were able to leverage the hierarchical design planning flow in order to budget out the sub-blocks. Unfortunately, it turned out that due to features in our design and also perhaps in IC compiler, we were not satisfied with the budgets that we got, and we had to write some custom code for doing the budgeting for each of the blocks and per scenario. This meant that the runtime was extremely high, and we wanted to do something about that. So by using this built-in budgeting task in Lynx, we started to break that down in order to see where we could optimize things, and it was fairly easy to play around with the flow, and we wanted to try and to parallelize some of the task. And as you can see here, we have a first draft of this, but this was kind of too static for us. We wanted something that was more dynamic, so that when we changed the setup, it had more or less scenarios that would be all automatic. And there we could use some of the other methodologies in the STA flow in Lynx for actually generating a bunch of tasks for each scenario. And as you can see, you cannot see, but the circle task there, actually when it runs, it will dynamically generate tasks for doing the budgeting per scenario. All right, and here you can see all the green ones that are aligned. They are the budgeting tasks that are running in parallel, and you could imagine if they all had to run in sequence, it would have taken a lot longer. This, by the way, is one of the nice charts that you can get out of the management cockpit, which is also part of Lynx. So to summarize, we had this successful project where we taped out 8 months after starting using the Lynx system. And the chip was actually a fairly complex multi-voltage design, and where we at the same time started using a new technology node. One of the things that we have been struggling a bit with is when we want to upgrade Lynx, we have to move some of the enhancements we have made ourselves into the new release, and that's a bit tedious as it is, but I guess that's some of the flexibility that we have to live with. And another thing is the management cockpit. Although it's a nice feature, I guess, for managers, it could be more engineering friendly in the way that you could pull out some of the metrics in your daily work into the execution environment. But in the end, Lynx provides many benefits for us. It allows us to easily adapt to new methodologies and tools. For instance, started using a multi-voltage design, power gating, and also, of course, hierarchical UPF for specifying power intent. And it kind of provides the glue between tools that often, as an EDA user, you kind of miss that when you get new tools. Lynx kind of has all the, at least the Synopsys tools integrated into to the flow, so you can easily start using them. And yeah, so Lynx allows us to work, instead of writing flow code, we can focus on what really matters to us, and that's creating low power physical designs. Thank you.